Welcome. 2.4, a practice understanding. So we're going to look at how we can use some of the log rules to solve problems. And they give us some values, like they give us the fact that the log of 6 base 2 is 2.585. That means that 2 to the 2.585 is approximately equal to 6. Now, because it is irrational, it's not going to be equal to it, but it's close. And you can check for reasonableness. The log base 2 of 4 is 2, because 2 squared is equal to 4. The log base 2 of 8 is equal to 3, and that's because 2 cubed is equal to 8. So therefore it seems to make sense that 6 is between 2 and 3, not halfway between. It's not a linear function, but between the two. So these were the product rules that you're going to use to solve problems. The product is the sum of these, the quotient is the difference, and the power, that k, is actually your exponent that you're solving for. So if that's given, you're multiplying. So now let's try a few. And we're going to use the idea here where they gave us for 3, 5, and 7, they gave us some values. So we're going to use those as approximates when we do these things. So the first one, log base 2 of 12. Well, 12 equals 6 times 2. So this one should be the log base 2 of 6 plus the log base 2 of 2. Okay, well, that log base 2 of 2 is 1, and 6 was given 1.58. Actually, no, it was given up here, 2.585. And so that will give us an approximation. Log base 2 of 7/3, we can use the quotient rule. So that would be log base 2. And by the way, sometimes you see the logs written where the argument, like the 7's not in parentheses. That's okay. I usually put that in there just to make it easier to read, but it's optional. Log base 2 of 3. And then I can just use the estimates here to subtract and come up with an estimate. Here, 30 is 5 times 2 times 3, so I could solve this log base 2 of 5, log base 2 of 2, and log base 2 of 3. Log base 2 of 2 is 1, 3 and 5 are given above, and then I'm going to subtract log base 2 of 7, which is also given. 46, we know 243 times 2, 3 to the 5th. So I could write this out as log base 2 of 2 plus log base 2 of 243. And just one note about this. Here, let's say this log base 2 of 2 is 1. This one we can write as log base 2 of 3 to the 5th. And so therefore we can do 5 times log base 2 of 3. What would you need for the rest? Well, notice since we're multiplying, if we can get the prime numbers, we should be able to do it for anything, right? All right. This one, is it always true, sometimes, or never, given a domain? Remember, here's the log function, so remember the domain. It doesn't actually cross the y-axis. So the domain, the x values, does not include 0. It does not include the negatives. It would be from 0 to infinity. So in this case, this would always be true. Okay. And you can try different x values. The second one is always true, And that is based on both the, when you look at properties, it's log product rule, log quotient rule. This one is log quotient rule. This is log quotient rule and log product rule. This one is never true, okay? The log of x minus the log of 5 equal to the log of x divided by the log of 5. Okay, I think that this one, the person is confusing log of x divided by 5. This one's always true by definition, and this is the log, and they call it power rule. So based on the log power rule, because remember, exponent, a log's an exponent, and if they give you the exponent, then you know that that's going to be part of the solution. This one I think they're also confusing. This would work if it was 5x squared.